de datos de energía renovable y el análisis del potencial energético renovable en el Perú, a cargo del señor Ron Benioff, director de programas para programas internacionales en el Laboratorio de Energías Renovables Nacional, el National Renewable Energy Laboratory, NREL.
Muchas gracias, Romano, and thank you for the opportunity to be here and talk about some exciting work that NREL has been doing in very close collaboration with MINEM and other partners here. I'll talk about work we're doing and a tool that we've developed that's available for free on renewable energy potential analysis, and also highlight a related tool, the Solar Advisor model, that's available for analysis of the generation and financial performance of renewable energy systems. And glad to find out ways in which we can work together with all of you here to help apply these tools. Just a word about the National Renewable Energy Laboratory. So it's a laboratory, I think the world's largest laboratory dedicated to renewable energy and energy efficiency, based in Golden, Colorado in the US. About 2,500 employees working there. The guts of the laboratory is research. So we have the world-class researchers working on the full suite of renewable energy power technologies, as well as sustainable transport and energy efficiency across end-use sectors, and very importantly also on energy systems integration, how to integrate renewable energy systems into the grid, and very advanced high-performance computing and visualization, and a deep program that also works on energy analysis and applications, as I'll talk about. We're very active internationally. We're active with over 90 countries around the world. We have a bilateral program here in Peru with support from USAID and the State Department. And we work on the full gambit of solutions, on advanced power, transport, buildings, and industry solutions, on grid integration and modernization, on microgrids and distributed energy programs, and also on strategies for low emissions development to deal with climate and economic development issues. So the work that I'll talk about is a partnership with USAID. We're working around the world to help countries with analysis, with informing policies and planning, and we have a whole series of toolkits that's available. The four main toolkits are summarized here. The one that I'll be focusing on particular is the Renewable Energy Explorer, re-explorer.org. These are all free toolkits. They're a collection of analysis tools and data, best practice reports, training resources, and we have a series of webinars, and can also offer some expert advisory support on use of the tools. So I'll focus on the RE Explorer, but just a word, the other ones, Greening the Grid is a whole series of tools on analysis, power system modeling, on engineering and operational solutions for renewable integration in the grid, and best practices on policies and market design to enable high amounts of renewable penetration into the grid. iJedi is a tool to evaluate the jobs and economic development impacts of renewable energy projects, and is a very popular tool to help make the case for the job and other economic benefits associated with investment in renewable energy. And our newest toolkit, the Resilient Energy Platform, shares best practices, strategies, and options for improving the reliability and resilience of energy systems in the face of natural disasters, to deal with cyber issues and other risks that energy systems face. So please take advantage of these tools and let me know if we can help you in any way in applying them. So the Renewable Energy Explorer is a web-based tool, and by the way, it's available for other countries, soon will be available for all countries in the world, thanks to support from USAID. It provides users with access to the latest renewable energy resource potential and a GIS framework, a geographic information system framework for overlaying renewable energy potential with other factors. And then to visualize results so you can understand the potential for renewable energy development in different regions and use the analysis as a basis for planning and informing policy and for investment decisions, very importantly. So the Data Explorer here in Peru has been developed in cooperation with MINEM and the NAMA project that's funded by the United Nations Development Program and the GEF. We're taking the solar and wind data from NASA-generated data sets, the National Solar Radiation Database and the Global Wind Atlas at a 4 kilometer by 4 kilometer grid scale. This is the solar radiation data that we're using for Peru. I think probably most of you are familiar with the tremendous resource potential Peru has in the west, especially in the southwest, but also good potential up to the north as well. And what this tool does is it overlays the resource potential for solar and wind with limitations on land use, maybe protected areas, areas that are water bodies that are built out, limitations on flat terrain where you can actually build solar and water systems, and other factors, and I'll show you the specific factors that were applied here in Peru to then identify what are both the best sites for development and what's the total potential available for renewable energy development. In Peru, focused on PV and CSP was the initial application of the tool here. So here are the inputs we used based on guidance from MINEM. We identified the minimum solar potential that would lead to a specific power density identified here for sites that had a minimum of 4 kilowatt per hour per meter squared per day for PV and 5 for CSP, since you need a little more concentrated and direct solar resource for CSP. We also limited to sites that were at least were 5 kilometers or less to transmission, so that it wouldn't be too costly to build a connecting line, and also 5 kilometers to roads so that equipment could come in for construction of grid-connected PV and CSP systems. So analysis I'm talking about here is specifically focused on potential for grid-connected solar systems. And we also excluded certain land use types, again based on guidance from MINEM, places that were already agricultural lands or protected forests or wetlands from the analysis. So this is available land with high renewable potential and close to transmission and roads. Here's the results for photovoltaic systems. You can see the locations, and if you go online and use the tool, you can zoom in a lot more detail to have a much finer resolution on the results. But you see along the west the great potential and very strong potential both in the south and in the north. The total potential with this screening, again screening based on resource, based on land use and proximity to grid and roads, shows that there's over 10 times as much potential for grid solar development compared to current generation of all types in the system in Peru. So there's economic and grid integration factors that need to be considered, but from a technical and land use perspective, Peru could get to 100% solar generation without a problem. Similarly for CSP, the concentrating solar power systems, we've identified potential generation for 375,000 gigawatt hours per year, I think over 6 times the current generation in the system here. And and similarly, similar locations a little more restricted because of the need for a little better solar resource for CSP development. We also looked at potential for distributed, so non-grid tied PV systems, and in this case we removed the constraints on distance to transmission and roads, and this increases the land area available substantially, as you'll see if you compare this map. Maybe I'll just go back to, so you can see here's a fairly small area for grid-connected PV, and if you look for distributed PV, a much larger land area would be available. And this is using fairly restrictive criteria on very high solar radiation opportunities, where you have in the Iquitos region, for example, which isn't showing up here, where you're paying a high cost for diesel, solar will be economic as well to replace diesel. And we've done a separate study that shows that even without batteries, it would be cheaper to replace 20–30% of the existing diesel with solar in the Iquitos region. And then if you add batteries, that potential is even higher. So here's the key conclusions from this screening analysis, and I do need to say this is a screening analysis. We haven't done grid integration studies, we haven't done full economic analysis, so this is a technical screening analysis. But from a technical perspective, there's huge potential for solar energy development in Peru, with the CSP, the concentrating solar power in the south, in the Sur region, PV spread throughout the country, but the highest potential in the Sur and Norte regions. And the solar generation can far exceed, by 10 times, Peru's current annual generation. Now, as I noted, these are a high order estimate. You need to factor in some further economic analysis and grid integration issues, but shows that from a technical standpoint, there's tremendous potential in Peru for development and can provide the basis for deeper site-specific or regional grid studies. Which leads me then to a next set of tools that can be applied. Two tools in particular that are available. These are available for free. The System Advisor Model, SAM, that can be used for solar, and the full suite of renewable generation technologies, and PV Watts, which is specifically looking at performance of grid-connected PV systems. And I'll elaborate further, especially on the System Advisor Model. For both tools, they're applying weather data plus system characteristics and losses to estimate electricity production, and in turn, what is the cost, what kind of compensation would be provided, what kind of financing. They have financial models embedded in the tools, and can then, based on those inputs and information, can then provide estimates of annual, hourly, monthly if you want, generation, capacity factors, levelized cost of energy, payback, and revenue streams associated with renewable energy projects. So this is for SAM, the System Advisor Model. We have the full range of technologies. Only a couple additions that are coming are marine energy systems and fuel cell technologies, but otherwise photovoltaics, wind, CSP, geothermal, biomass, and solar hot water, and can look at a whole range of different financial structures, whether this is a behind-the-meter system for residential or commercial, or whether it's a power purchase agreement that's being established with different ownership models, or a developer owned system. So the Solar Advisor Model is used by lots of different folks. It's used by those looking at from a regulatory perspective and a planning perspective. How would the different systems, how would they affect rate structures and in turn inform the planning, the integrated resource planning process for utility. Very heavily used by developers and engineers to optimize system design and figure out the best design for different locations and what's the levelized cost of energy that an individual system will produce. The system advisor model has also been actively used by researchers who want to play with innovative designs, innovative financial structures, and understanding the technical and economic potential for a system, and of course by students as well. So there's a larger suite of tools and models that can and need to be used often. So I've been talking about the system advisor model and PV watts, which are used mainly by engineers and developers and installers. But if you're interested in looking at, if you're a utility or a regulator, system operator, there's tools available for looking at the grid integration issues. It can be capacity expansion models used for planning for grid integration, or production cost used to figure out what's the optimal mix to achieve certain cost targets. And those tools, we've worked with various countries at a regional and national level on grid integration studies to answer key questions about how much solar and wind and other technologies can be integrated into the grid and what steps are necessary to enable grid integration. What size of a balancing area is needed, what type of grid controls, what type of voltage and frequency regulation, improved forecasting, what kind of storage or flexible backup generation is needed, and very happy to work together with you and others for deeper grid integration studies here in Peru as needed to help look at more detailed scenarios. For the system advisor model, here's the website, sam.nrel.gov. We have a very active support forum. You can ask questions, get quick response. We have a very large user base. There's a YouTube channel. We have frequent web seminars, bi-monthly roundtable discussions that are interactive, and of course email support and phone support is available as well. So I hope you'll use the tool and also use the Data Explorer to understand sort of the technical potential. And here's my contact information. Glad to have you contact me, and if it's a technical question, I'll put you in touch with our Renewable Data Explorer team, our System Advisor team, and our other analysts working on different tools and methods. So I'll stop there. Glad to have a few minutes, I think, if there's a question or two, and I'll also be available afterwards. Thanks for the opportunity.
¿Aló? Tenemos tiempo para 2 preguntas breves, por favor. ¿Hay algún interesado en preguntar? ¿Ninguna pregunta? Ok. Se le va a hacer entrega de un presente de parte de la organización. Muchísimas gracias.